I know with Christmas in between it might be difficult to remember here, but we did start talking about angles and circles and radian measure, and I think we had just got to the point of what a radian was and starting to write some different angles. Whether or not you did that first activity and all of this, I think we were kind of at the point of just trying to look at what some angles were in degrees and what those angles were in radians. Maybe we will go to this to try and remember that. The angle it's in, so this is a circle here where a point that I can move around the edge. The angle in radians is shown here, and the angle in degrees is also shown here. 1 degree is this tiny little angle down here that it won't even let me go down that far because it'll snap right to the bottom axis. But an angle of 1 degree is a pretty small angle. An angle of 1 radian is about there. An angle of 1 radian is when the arc length, the distance around the circle. So this is equal to this. So I haven't got it quite to 1 radian here, but I will try my best to land right on there. So that's 1 radian. 1 radian is when that distance is the same as this distance. It's actually quite far around a circle. Let's pause it. If this radius is 1 centimeter, how far around is it, this arc length here? How far around is the whole circle? Well, the circumference of a circle is 2 pi times the radius, right? So it's going to be, if you go all the way around here, it's going to be, you can't see it, but what is it here? It's going to get up to what? 6.28. It's going to be twice what pi is. Halfway around is going to be pi, or 3.14, right? All the way around is 2 pi. All that radian measure is defining the angle as that value when the radius is 1. Okay? The angle in radians is the distance around a unit circle being a circle with a radius of 1. So 1 radian is about 57 degrees. 2 radians is in here somewhere. 3 radians is just before halfway, and halfway around is pi. 4 is over there somewhere. You might know these ones. This one is 1.5 times pi, right? Because that's 1 times pi. 1.5 times pi. This would be a half of pi, a half of 3.14, which is, well, I haven't got it quite on there, but 1.57, when that's a right angle. So I think what we had started and then didn't finish, or maybe you had finished, is to try and make a list of some of the common angles and what they are in radians. And I asked you to write them as kind of multiples of pi and as decimals. I gave you some kind of samples there. If you prefer this, if you're a more visual person, and if you didn't do this, or even if you did do this, it would probably be a good activity to redo, given that there's been a 2-week break in between. It might be useful for you to draw a circle and then actually show it visually, I think. So what you could do is you could put a set of axes down there, or you could draw some lines here, or just do little tick marks on the edge or something like that if you want. Okay, actually it'd be better if you had some axes on there. You don't really need a circle, but you could do some kind of drawing where you have axes like that, and then you can say that angle, right? You can say that if this is 0, this is pi, and then this you could say is 2 pi all the way around, right? What did we say that was? You could either write it as 0.5 pi, half pi, or pi over 2, or approximately 1.57. I'm going to leave it to you to organize it because I've already started in a not a very organized fashion here. Maybe you could do it like that. And then down here, this could be pi or 3.14 roughly. 0 is just 0. 2 pi or 6.28. Those are the same, right? These two angles are called coterminal. They end in the same place. Whether you don't turn around at all or you go one complete turn, You can't tell the difference, right? Once the angle is there. You could do the one that's down here. Whoops. This angle all the way down to there is, what did we say it was? It's 1.5 pi, or 3/2 pi, 1.5 pi, or 3 pi divided by 2, or as a decimal, 4.71, roughly. I would like you to put some of the other ones in here. I would like you to put the ones that are related to 30 degrees. So you might actually put in here what it is in degrees as well, 90 degrees. So I want you to put the ones that are related to 30 degrees. So what other ones are related to 30 degrees? This one's related to 30 degrees. What would that one be? If this was 30 degrees, what would this angle be? Let's do 150. That's an angle we could do. We could do this one. What would that angle be? If this was 30, how much would this be? 180 and 30, you could do 210. And you could do this one over here. What would that all the way around to there be if this was 30? 330. So do the angles that are related to each little angle that you happen to do. You could do a different picture if you want, or you could do a different color if you want, or something for the angles related to 60 degrees. Right? If this angle was 60, think about what that would be. 120. And then the only other ones might be the ones related to halfway in between here. What's halfway in between there? 45 degrees. You could do the ones related to 45 degrees. Can you try and make a list there of what they are as multiples or fractions of pi, and what they are as decimals? I'm thinking this might take a little while, but it is well worth your doing. If it helps you to show them, it's going to turn into a mess if you try to show each angle as a rotation like this, because I'll run out of space, but you could think about that as you're doing this. Okay, can you do that right now, please? If you haven't already done so. And then we're going to talk about the other things. Think about it in terms of fractions. Pi is right there. Pi is also 180 degrees. So think about it in terms of what fraction of 180 degrees is it? Let's do one together here, like this one. 120. I think you can do this. What fraction of 180 is 120? If you had 120 out of 180, what fraction is that? It's 2/3. So this one is 2/3 pi, or 2 pi over 3. Think about what fraction of 180 it is. What would this one be down here? If this is 45 degrees here, that is 180 plus 45, 225. What fraction of 180 is that? Can you think about what fraction of 180 it is? Count by 45s here. You can count with me. There's 45. There's 90. There's another 45. That's 3 of them. There's 4 of them. There's 5 of them. What fraction of 180 is that? It's 5/4, right? If you can see that right away, you can say it's 5/4 pi, or you could say it's 225 out of 180. Whoops. 225 out of 180 pi. You can write it as a fraction like that if you want, 225 out of 180, or you can just simplify it in your head, 5/4 pi. Can we spend some time doing that? I'm going to pause this or stop it.